got a fantastic one with Brian here, and he is going over Hunting We Will Go, Adventures in Endpoint Threat Detection. And he's elected to introduce himself, so I will let you have the floor, sir.
All right. So it's there. So my name's not actually Brian, but it's Dave Branscome. I'm with Microsoft. I'm a senior cloud security architect, so I work with Microsoft partners on helping them understand how to use Microsoft security products. So as you can guess, this presentation is going to be fairly heavy on the Microsoft product and solution side of things. But I think you'll still enjoy it. I think there's some interesting ways that we approach threat detection that will be interesting for you. So let's get started. And I even tried to match the colors for the conference here today. So anybody's free to email me if you have any questions about the presentation. Feel free to go ahead and do that. Let me stop my video. There we go. All right, so let's get into this. So the problem, what is the problem that we're trying to solve here? The problem is this. So a lot of the methods that people use to approach network defense, they go wrong before there's any contact with an adversary, to be honest. And that starts with how defenders think about the battlefield as they're approaching defending a network. Most defenders focus on protecting their assets. So they may prioritize them, they sort them by workload, they sort them maybe by business function. And so they have this list of assets. It might be a system management type of service, might be an asset inventory database, maybe a BCDR spreadsheet, whatever it might be. They've got this list of assets that they feel need to be defended. The problem with this is that attackers breach a network by landing somewhere in the network using a technique that could be as simple as phishing, right? It's a phishing email. And once they have that entry point into the network, from there, they pivot, they move laterally. They aren't following the list of defenses that you've so carefully laid out in advance. They go wherever the network allows them to move. And that's what's being described in this quote. Defenders think in lists, attackers think in graphs. As long as this is true, attackers win. So an attacker doesn't care where they are. They just move from where they can move. And so as defenders for years, we've built our defenses based on the assumption that attackers are going to launch their attacks kind of in the order that we have prioritized our defenses. So we think of, that our firewall is going to be the first thing that they're going to hit, and then they'll go through our IDS or IPS, and then they'll hit our, whatever kind of, our message hygiene system. Then they'll hit whatever comes next, and that the very last thing, the thing that's furthest, deepest in the network, is the crown jewels that we're defending. That's not how the attacks actually play out. Attackers don't care where their entry into the network is. They only care that they get in. And from there, they figure out a way to move once they're inside the network. That's the problem that we're trying to solve, is how do we identify somebody wherever they land and defend from there? And so for the remainder of this discussion, what we're going to do is go through this scenario. So the scenario is we've got an attacker, and the way that he's approaching this, and this is very, very common. This is the method that's being used here is, you might see this in 80, 85%, maybe more of the attacks that are launched against a typical Windows network. So you've got an attacker, he sends an email with a malicious link or some sort of attachment. It lands in somebody's mailbox. We'll call her Barbara. She clicks on the link. She downloads the document. It's been weaponized somehow. It installs some piece of malware on the machine. Her machine is now compromised. Because her machine is compromised, the account that she uses to log into that machine is compromised. Now the attacker starts looking around, starts trying to figure out, okay, what else can I get off this machine? And so they're able to identify that Eric, who is a member of the help desk team, he's also logged onto this machine. So what can I do with Eric's account? Well, we find out that he's a help desk systems guy. And so maybe he's got local administrator accounts on other machines. So let's pivot over to his machine. Let's start using his account to do some queries against Active Directory. And then we can maybe compromise the global systems admin account or the domain admin account and compromise his computer. Then from there, we can make some attacks against the Active Directory domain controllers, dump the NTDS DIT, and then exfiltrate that data using an inbox forwarding rule. So this is the scenario that plays out time and time and time again on networks. This is almost you could write this down. This is how MITRE structures their framework. This is the type of path that an attacker uses to compromise a network. And so this is what we're going to be looking at. We're going to be seeing what are the tools that you can use in a Microsoft network to identify this path and figure out where they're going. Because if you think about it, they're touching a lot of different systems. Number one, they're touching the email system. They're touching the computers. They're touching user accounts, multiple user accounts. They're touching Active Directory, right? So it's not just a single endpoint that that you can monitor and be watching for something specific to happen on an endpoint. You have to be looking at a variety of different systems and stitching that whole story together. And that's where many systems have a problem. So let's go hunting. All right, so the first thing that we're going to do is we're going to pretend that we're the SecOps team. And we've got our incidents open here in the browser. We've got a couple different locations open. These are all Microsoft tools, obviously. And each one of them has a different alert open. But we need to figure out how these alerts relate to one another. So as we're looking at this particular alert, we see that in this case, there was an email message that contained malware that was removed after delivery. So in some cases, what happens is malware, whether it's in the form of an attachment or a phishing URL or whatever it might be, does actually get delivered to a user's mailbox before message hygiene systems have a chance to detect it. When that happens, you can get messages like this or alerts like this. Email messages containing malware were removed after delivery. When this happens, if you have Microsoft Defender for Office 365 set up, we use a mechanism called ZAP, Z-A-P. What that stands for is 0 hour auto purge. And so what we can do is go in after the fact and remove malware that has been that's been able to evade the message hygiene systems initially. You can remove it after the fact. And that's what we see here. It says, by the time this alert was triggered, the following 3 users received malware, phish, and malicious mail matching the conditions of your alert policy. And we see the users that are that receive this message here. So these kind of alerts are fairly common in large organizations, and it just underscores the fact that sometimes files slip through the cracks. Now let's go over to our Defender page here. Now what we see here is a little bit different area that we're looking at. So here we see that there was a possible credential theft from the NTDS DIT. So those of you that are familiar with Active Directory, you know that NTDS DIT is the Active Directory database. It's the directory services database. So this is where all the Active Directory information is stored. So things like password hashes and user accounts, IDs, and computer machine names, and all that kind of stuff is stored in the NTDS DIT. So if you're able to acquire this file, it allows an attacker to gather information about all the users that exist in that Active Directory domain and then steal their credentials. So with that credential information, they can then elevate their permissions to get to the assets that they really want to get to. And that's what we see taking place here. There's a possible credential theft from NTDS DIT. Let's go to the CloudApp Security. So if you're not familiar with what CloudApp Security is, this is our CASB, so a Cloud Access Security Broker. It's what allows you to filter access to cloud applications or SaaS apps. So you might be connecting to Salesforce or Google or Okta or whatever it might be as a cloud app, and it can be filtered through CloudApp Security, so we can monitor what's taking place on even those third-party applications. So when the security operations people go in here, they see that there is a suspected overpass the hash attack. So for those of you that may not be familiar with what this is a lateral movement technique where an attacker will steal an NTLM hash, and they will then create a forged Kerberos ticket from it in order to gain the permissions of a more privileged user. And so in this case, if we look down here, we see that Annette's credentials were stolen and were used successfully to authenticate to another PC. Finally, in the incident alerts, here we have an aggregation of the alerts that are related to a single incident. Okay, so we've got an incident here, and these are the alerts that were pulled together as part of the overall incident. Now you notice right here, we've got the alert that we saw a little bit earlier that said email messages containing malware removed after delivery. Remember, that was in the first tab that we saw up here. That's part of this overall incident. If we scroll down a little bit, we see also the possible credential theft from the NTDS DIT. Okay, so essentially what we've done here is we've pulled together the alerts from these other systems into a single incident so that we can start to make sense of how an attack was performed. Let's scroll over. So remember, we're on the third line from the bottom here, successful logon using potentially stolen credentials. We scroll over, 1, 2, 3. Now, what I want you to notice here is that the service source or where the signals are coming from are different locations. So some of it is coming from Defender ATP. So Defender ATP is the endpoint detection and response or remediation tool that we run on endpoints. But we also have CloudApp Security, which I mentioned is our cloud access security broker. You could also see in here alerts related to, excuse me, identity or Office 365 security. So now what the SecOps people want to do is understand how all these alerts got correlated together and start investigating the incident itself. So let's go ahead and close these browsers. Okay. And what we want to do here now is we've opened up we've got the alert tab open. These are all the alerts that are related to the specific incident. But now let's go to the summary page and kind of get a big picture view of what's taking place in this incident. So if you're a SecOps guy, you come in here and you get a high level overview of the entire incident, like at a 30,000 foot view. Now, first of all, we've got this indication of progression against the MITRE attack framework. So it shows us how far along the attacker has progressed in the MITRE attack framework. We also see things like the scope, how many impacted devices are part of the incident, how many users, how many mailboxes. We also have, as part of this alerts and categories, we have the MITRE attack progression, but we also see down here the timeline, the alert chain. So when things happened in sequence, right? Even though they may be sending alerts from different locations. So we've also got here the impacted entities. And so we've got a description of how many devices use their mailboxes, but which devices, which users, and which mailboxes have been impacted. And what we see here is we also have an indicator of the risk level of that device or user being compromised. Okay, so at a very high level, we can understand what is the risk that's posed by this particular attack. We scroll down and we just see kind of follow the timeline as it gets further and further along the progression, and you can see again, which PCs have been impacted, connections to the domain controllers, use of suspicious behavior in Microsoft Word, so some sort of malware in Word, PowerShell command line, so on. So one of the other things that this gives us, and we can see this in some other locations as well, is things related to the groupings of the machines that were found. So if we look down here, we can tag groups of machines or groups of users so that, for example, if they were all part of a particular incident, if you have an incident numbering system, say this was incident 6543, right? You could tag all the impacted entities with that incident number so that you can keep track of what's actually going on, and then you can remove those tags after the fact. Now, what I want to do here is go in here and click on View Alerts. And so we're back here where we started from, right? These are the alerts that are all correlated back to this one incident. So let's go to the malicious file was detected based on indication provided by Office 365. So SecOps now digs into this alert so that they can gather more information and see how this incident has been moving along. So one thing you want to understand here is that in M365, if an alert is triggered, on the back end, we have what are called security playbooks that are kicked off. These are automatic. These are built into Office 365, but you can build your own as well. These are back-end policies that are at the heart of automation in the Defender framework. So a security playbook is launched automatically when a specific alert is triggered within the organization. So once that alert triggers, the playbook is run using what we call the automated investigation and response system. And we see that that's what took place right here. It says that when this malicious file was detected, an automated investigation was kicked off. So the investigation looks at all the associated metadata of the specific alert. So that might be the email message, it might be a user, it might be a device, whatever it is. And then based on the investigation playbook's findings, the automated investigation and response system provides a set of recommendations or actions that your security team can take to control and mitigate the threat. So in this case, it fully remediated this particular threat, but it could, as we'll see in some of these others, it could have failed or been unable to remediate the threat, in which case maybe you need to go in here and do some more, or you have to categorize it differently and indicate that it needs to be investigated by a security analyst. Let's go over here to investigations. When we go into the investigations tab, within the overall incident, remember we're still in the same incident, you can see all the automated investigations that have been kicked off as a result of this one incident. So there's a lot of alerts that go along with this incident, and multiple investigations that were kicked off automatically. So this gives our SecOps team the ability to review the investigations that have already taken place, what their status is, if they've been remediated, if they failed, or if no threats were found, as well as where the alert came from, right? If it came from Office, if it came from Defender, if it came from identity protections, how long that investigation took, right? It ran the investigation. Some of them take longer, some of them are fairly quick. But the SecOps team now can then take a closer look at this investigation and figure out what's going on. So let's take a look at this one up here, the malicious file detected based on indication provided by Office 365. So now we're getting into the actual investigation that was part of the incident, okay? So what the graph here shows us is that when this alert was triggered and the security playbook was kicked off, there was a potential issue found in a file that was delivered to the user through Office 365. Okay, so the file was delivered, it landed at some point on Barbara's PC, then this security playbook kicked off. It started analyzing all the components of Barbara's PC. It investigated all the files, processes, services, drivers, IP addresses that she's been connected to. It looked for different persistence methods for attackers. It found one file that needed to be remediated, and it was successful in that remediation. Now, one thing that needs to be pointed out here is that this was able to take place because Barbara's PC is categorized in Defender as an automated or a fully automated remediation PC. So you can define groups of PCs differently. You can say these machines will be fully automated in their remediation. This other set will be semi-automated remediation, and this other set will have no automation of the remediation. Now, why would you want to not automate the remediation? Well, in some environments, for example, we call it medical research and stuff like that, pharmaceuticals, that's what I'm trying to think of. They may have machines that you are not allowed to alter the configuration of them, even if they get a virus on them. You're not allowed to automate a remediation of that machine without some sort of change control process in place, or else it can nullify the testing that's taking place on that machine. So there may be some machines that you don't want to automate the remediation of them, or it could be controlling some sort of industrial system or something on a factory floor that the machine can't go down, things like that. But in Barbara's case, her machine falls into the category of go ahead and fix it. So that's what happened. Let's go to devices. So here in the devices, we see which devices were impacted by this particular incident. And so if we highlight Barbara's machine, with this little flyout, we see information about what domain she's a member of, what the OS is. We see things like the data sensitivity. So like I was talking about earlier, we can tag her machine with different tags, and we can say that it may have highly confidential data. It has data that's a sensitivity of high. We can put whatever tags we want on here. And particularly if we tag it as a device value high, then a compromise or an alert that is generated by this machine will be given higher priority to remediate than just a standard user machine, because this one has very confidential information, very important information. So we can be, give this one the first set of eyeballs that are available. We scroll down. We see the active alerts and the severity of the alerts that are associated with this. Remember in our original diagram of what we saw happening, one of the things that we saw was that the attacker pulled the credentials. Once the attacker was able to compromise Barbara's PC, they also compromised the credentials of Eric, who had local admin privileges on Barbara's PC. And so that's where we see that this was made possible, because at some point, Eric has logged on to Barbara's PC, and there are stored credentials that, the attacker was able to extract. Let's go back up to the root of the incident and go to the alerts tab once again. And let's go to the email messages containing malware removed after delivery. All right, so here we've got an overview of this particular alert. We see that, again, it was resolved. It was identified as a true alert, security testing. We see that the email with malware that was delivered and later removed, right? So this is very similar to the one that we saw earlier. Let's go to investigations. All right, so the SecOps team takes a closer look at the investigation of this individual investigation, where it says mail with malware is zapped. So let's open that. And again, over on this side, we've got a little bit of information about this particular playbook that was run. Now, this ID, we're going to click on this ID. This is a clickable link. And this pulls up another graph. Let's take a look at the alerts tab. And here we see the alert that triggered the event is a zapped malware alert. Now, in the details section, we see that Barbara, her email box or her email account is the one that was involved in this particular incident, this investigation. So let's close this. And we'll go to the email tab. Now, this is a pretty interesting tab for investigation. So we'll come back to this, but right now what we're going to do is look at the entity value here, the email received by the user Barbara. So this particular alert got into the incident, the overall incident, because it triggered the same user mailbox, BA Morel at mtpdemos.net of Barbara. Right? We see also the sender is mtpdemos@juno.com. Okay, so keep that in the back of your mind, that's where that email came from. Okay, so now we go back to this email contains view. Now what we're looking at here, again, we've zapped the email that contained malware, but we want to understand where else did this mail go to? Where else in my environment did it go to? And so we have to make some determinations about where it came from, what it looks like, what attachments, what subject line, and so forth. So we're going to be looking at email that contained an attachment that had this hash. We're going to be looking at email that came within the cluster from the sender domain of juno.com. We're going to be looking at email that had this particular subject line. We'll be looking at email that came from the cluster of this sender IP. And then there's something a little bit different about this subject line. I haven't been able to figure out exactly what's in between these two, but maybe it's something in the details of it. But the point is, with each of these details about the email that was zapped, we see what happened with those. It was classified as malware, it was classified as phishing, it went to junk, it was blocked, whatever the disposition of that email is. So this helps us narrow down where else this particular email might have landed within our environment. All right, let's close this down. So we now know that the malware didn't stop at Barbara's mailbox, right? We know that the machine had Eric's log on as well. And we know that the email went potentially to multiple other mailboxes. And so we need to figure out how far this may have gone. So we go to alerts. And if we scroll down, so if we go through the list of the alerts related to the same incident, we're still in the same incident, we see that recently one of the users had an open session to the domain controller using server message blocker, SMB, right? So we also see here user and IP address reconnaissance using SMB. So let's take a look there. And here we've got more details about that specific alert. So we can see, again, why this got correlated into this particular incident. What was it about this alert that linked it to this incident? Well, it was because it was initiated from Barbara's PC, and these SMB sessions were enumerated connecting to this domain controller. And there were 2 IP addresses that were identified. Now, let's go in here and open the alert page. All right, now we flipped over to CloudApp Security. So we want to get some more information about what's taking place here. We see that there was this SMB enumeration taking place. We see where it was running from. For example, we see that the enumeration was from Barbara's machine, or we see that it was exposed through the connection to the domain controller. We also see this other one to Peter K's PC as well. So this gives us a little bit more information about what was taking place, but we see that this was being initiated from Barbara's PC. So again, the attacker is trying to get more information about the network so that he can move and pivot. All right, let's close this. And we'll go to the users tab in the same incident. Okay, so here are the 3 users that are correlated to this one incident. Barbara, the initial one that clicked on the email, Eric, who's the help desk guy, and then this other person. So let's open up Barbara and see what we can find out about her. Very quickly, we can see her user ID. We get a little bit of information. We know that she's in the finance department, which might explain why her machine was considered a highly sensitive machine. But what we want to do is get more details. So let's open the user page. Now, when we look at Barbara's user page, we can see the investigation priority that's been assigned to Barbara, which is, this is a fairly high risk level in Azure AD. And the reason is because there are 270 or a value of 270 on the alerts, and then the risky activities that are associated with her has a score of 2. So each risky activity has a point value, as you can see down here, and the more serious the alert, the higher the point value. In the user exposure section over here, we see which devices, or how many devices technically, we see how many devices Barbara has logged into. We see what locations she logs into, what resources she has access to, and so on. Scroll down a little bit. We also get information about her contact information, where she is located, her phone number. We see that she's located in Washington. Now, why does this matter? Well, if we see that one of the incidents related to her is that there was activity from an infrequent country, then the fact that she's based in Washington, we could call and ask her, have you been in a foreign country anytime recently, right? That'll help us to narrow down whether some of these alerts are false positives or if they're legitimate. If we dig a little bit deeper, our SecOps engineer can check the investigation priority of Barbara, where she stands in the organization. So she's in the top 90% of the organization in terms of priority of investigation. So she's a highly prioritized user to investigate. This is based on the alerts and the risky activities that are associated with her account. We also have the individual alerts in the timeline, and what took place with each of those alerts. Let's go ahead and close this. Now, what we want to do from here is take advantage of this tool, or this little button here. It says Go Hunt. And what this is going to do is automatically create a query based on Barbara Moreland and everything that's related to this incident. So we don't have to create the query that we're going to kick off here. So we click Go Hunt. It takes us to Microsoft 365 Security and this hunting, and then there's an advanced hunting tab underneath this. So hunting serves two different use cases. Either you've got an investigation that starts from an ongoing investigation, which is what we're doing right now, or maybe a hypothesis-driven investigation. You think that something may be true in your environment, but you need to prove it. So the queries that we're using here, or the tool that we're using here, uses KQL, Kusto Query Language. Kusto Query Language is a really powerful tool. It lets you sort through tons of records in a very short amount of time. This query language is also what is used in Azure Log Analytics. It's what's used in Azure Sentinel. If you're using Azure Sentinel as your cloud native SIM, it's also what is used for Microsoft Defender for searching endpoints. Okay, so with this advanced hunting tool set, the SecOps team can hunt the telemetry data that has originated from Microsoft Defender for Office, including things like email transactions, as well as your device telemetry from Defender for Endpoint. And we can even get information out of CloudApp Security and Microsoft Defender for Identity. This is the schema that you use to structure your queries, so you can start to understand how you would correlate or pull information about identity or directory events or things like that, how you would use them in a query. And so in this particular case, I don't need all of this data, so I'm going to remove some of it. And so now we've got this narrowed down to just investigating Barbara. Okay, so I run the query. And you notice down here, I've got some results back. So we can look at some interesting things taking place here. We see that Barbara, her account was used to run some queries, as well as Eric's account was used to run some queries. There was an enumeration of groups, so probably the attacker was trying to figure out which groups Eric might be a member of. Continuing on, there's some additional queries against Active Directory. Here we see one querying the domain admins group, right? So in this case, the attacker is probably trying to figure out whose machine do I want to get to next. in order to move laterally. So we know that Roberto is a domain admin, okay? Eric is a member of the help desk, and he also likely has the ability to query Active Directory and identify who the members of the domain admins are. So what we want to do is figure out, what did the attacker do with this information? So if we go up here and close the browser tab, we are back in the alerts tab. And so what we want to find out is how the attacker tries to gain the credentials of the more privileged user and to move laterally. So we see down here an attempt to do some reconnaissance, user and IP address reconnaissance over SMB. We can see that there was a couple credential theft activity alerts that were generated. We also see some stuff happening with Mimikatz. Right? Scroll down. And again, we see some credential theft. And here we see the credential theft from the NTDS DIT. So we can now conclude, as a security team, we can conclude that any of the users who logged into Barbara's PC, which at this point is just Barbara and Eric, we know that they have been compromised. So not only is Barbara's account compromised, but also Eric is as well. So let's go to user accounts and start investigating Eric. So we go to Eric. Again, we get some information about him. We quickly can see that he's a member of the information technology group. He's a help desk supervisor. So again, he's probably got local admin on not just Barbara's machine, but on a variety of machines throughout the network. So that explains how he made a lateral movement over to Roberto's PC to get the domain admin credentials. Let's go to alerts again. And we're going to just scoot over to the next page. So here we have the alert related to the overpass the hash attack. Okay, so let's investigate this a little bit. And we're going to scroll down in the alert. Notice we've got an alert description here. Roberto, who is the infrastructure services manager on this particular machine, he was successfully authenticated against the domain controller. Notice that this alert is considered a high impact alert, a high severity alert, because the type of alert this is, but also who it's against, right? It's against a person that has very high privileges, connecting to a domain controller, and so on. And we also see here, besides the individual alerts that are associated with the attack, we see some information about the top impacted entities. So if we expand that, it's Roberto's machine and Roberto's user account. Okay. Let's go back to the first page. Let's scroll down a little bit. All right. We also see here an LSAS process taking place, or a suspicious LSAS process access. On the third line from the bottom here, we also see a successful logon using potentially stolen credentials. Okay, so all this is related to this overpass the hash attack. We've extracted users' credentials. Now we're using it to log on using those stolen credentials. We scroll over again, remembering that this is on the third line. We see that the detection source is from Defender ATP. So on the machine itself, on the domain controller in this case, we see that this attack was performed. So this is one of the features or functionalities that Defender provides, is being able to detect these types of anomalies and correlating alerts and events that come from a variety of different Microsoft security products. Let's scroll back over. All right, and let's take a look at this suspicious LSAS process access. All right, this alert was triggered due to the first identity attack that we saw, the overpass the hash attack, and it was then enriched with additional data and activities that were observed on the same device. Okay, so if we look down here, we see what else was taking place. We see that this LSAS process access was observed in relation to an overpass the hash attack. This involves obtaining a password hash from memory and then using the hash to obtain a curb ticket. Ticket is then used to authenticate to network resources. Okay, so this helps us to do the rest of the correlations and help to combine all the activities that we've been looking at so far into this single incident and see how things have progressed and see how the attacker has moved and escalated their privileges. Let's move on down here. So with the credentials of Roberto at his disposal, the attacker then was able to move laterally to the domain controller and get access to the domain controller. All right, so let's close the alert pane here. Now we go back here to this alert with the possible credential theft from NTDS DIT. So the attacker, whoever it was, dumped the NTDS DIT in order to obtain users' credentials that are stored on the domain controller. So the security operations team now knows that Roberto's account was the account that was used to dump the directory services data from the domain controller that is MTP error DCO1 blah blah blah. Okay. If you look at the details over here, I just kind of want to point something out. It's not directly related to the investigation process, but I want you to understand that throughout all the tools that we're looking at, we're correlating the things that are happening back to the MITRE ATT&CK framework, right? And these are clickable. So if you click on this, you can see, for example, not just what credential dumping is, what phase of the MITRE ATT&CK framework this generally correlates to, but it'll also give you information about who the adversaries are that typically use this type of technique. And so if you're looking